Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topic, that is how to read the pile cap drawings and how to prepare the pile cap bar bending schedule. So stay tuned until the end to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's jump into the subject, how to read the pile cap drawings and how to do the bar bending schedule of a pile cap. See, here is an example of pile. You see PC1, 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 PC1. These are all the pile cap. And here we are discussing about PC1. Let's say example. So what is the dimension of the PC1? That is 2300, and here in this direction 800. So from the plan, what we are getting, that dimension of the pile cap is 2300 into 800. But what is the depth of the pile cap? That we will find out from the section. We will go later. So from here itself, what we are getting extra, that there is a column, that is P1, and P1 is dimension here, it is 600 and it is a 400. So 600 into 400 is the dimension, and there is a two pile group. So there are two pile, here one, and center to center distance is 1500. So from this, we are getting the details. Yes, now we need to check the details of this pile cap in order to get the do the bar bending schedule. So how can we get that one? Here is a pile cap details. Pile cap P1 and pedestal mark P1. So PC1 and P1. Now, here itself, we can see the dimension here it is 2300, here it is 800, as already we know. Now from here we can see there are two piles, the center 1500 and the pedestal 600 by 400. That already we find out from the plan. Now here it is, see, there is a reinforcement details is available. So here it is a farm line and another is dotted line. The farm one is for the bottom and the dotted for the top. So for the farm line, here find this bar from here to here, that means in the longer direction, it's from this point to this point is 20 or 125 center to center. So longer direction bar is 20 or 125 center to center in the bottom. Now what will be the other direction? See, other direction is the this bar. From here to here, it is 12 torr at the rate of 100 center to center. So bottom in the longer direction, 20 torr at the rate of 125, in the shorter direction 12 at the rate of 100 center center. So bottom reinforcement we already find out. Now we need to find out the top reinforcement. Top is the dotted line. This is the dotted line. So what it is, from this place to this place, from this place to this place, from the top bar, from longer for the longer direction, it is 12 torr at the rate of 100 center center top. So in the longer direction, in the top reinforcement in 12 torr, and for the shorter direction, that is this bar and this bar from this to this, that is also 12 torr 100 center center. So in the bottom, in the longer direction, 20 torr at the rate of 125 center center, and in the other direction 12 torr at the rate of 100 center center, and in the top both the direction is 12 torr at the rate of 100 center to center. So we are getting the reinforcement of the pile cap. Now how it will be distributed, that we need to know from the section. So section 1 we need to check. Here is the section. So in this section, what we are saying, here it is a 700, that is 700 is the pile cap depth. Now my dimension is completed, 2300 into 800 into 700. Now here, from here you can see the distribution. Main rod is 12 torr here, 12 torr at the 125 center center, and then distribution 12 torr 100 center center. In the top, both the direction is 12 torr at the 100 center center. Now here you can see there are two the reinforcement is there, that is called the skin reinforcement or the face reinforcement. In the pile cap, we are providing this skin reinforcement or the face reinforcement or the side face reinforcement. So what is that? 12 torr at the rate of 150 center center. So the face bar or the skin reinforcement is 12 torr at the rate of 150 center center. So now I find out the pile cap dimension. I find out the pile cap reinforcement top and bottom and how they are distributed, which one is the longer span, which one is the shorter span, that I will discuss, and also the distribution of the phase bar. Now here there is a column. So if we need to know the column reinforcement. And from the drawing you can say here is also beam, pile cap beam. This is pile beam that is marked PB1. That also we need to check. For now today also only pile cap and the column we will check, not the pile cap beam. But from here we find out that there is a pile cap beam. So whenever we are doing any bar bending schedule, that also pile cap beam also we need to prepare. But whenever doing also work that side, that pile cap beam also need to be constructed. Now here is a pedestal reinforcement or the column reinforcement. Now here it is, see here is the bottom of pile cap, that is minus 2.975, and you can see here there is the top of pedestal is 0.975, and above that there is the anchor blow bolt, that means the PB structure will come. So we need to cast up to this. So from point minus 2.975 to plus 0.975 we need to cast the pedestal. Why this dimension is important? Because whenever we are doing the bar bending schedule for the column or the pedestal, that dimension is required to find out the vertical length. So we find out the top and the bottom level also. Now you can check here is a there is also grade beam. So in this level also we need to put a grade beam, that is in the from finished ground level 100 down is the top of the grade beam. But from the simplicity we are not discussing about the grade beam, only pedestal. Now what is the pedestal reinforcement? Here it is section 2. Now section 2 we need to check. See here it is section 2. In section 2 what is saying? That is main bar or the vertical bar here, 4 numbers 20 tur at the corner. So all the 4 corner, one here, one here, one here will be 20 dia bar, and other 8 numbers 16. So 1, 2, 3, 4, 5, 6, 7, 8, that will be 16 dia bar. So what is the column reinforcement? 4 number 20 dia at the corner, and another 2, 2, 2, 2 in every direction is distributed, 8 number 16. So the total 12 dot. Now there is the links or the ties. So here you can say there are 3 types of the one is the total, one is in the middle one in the shorter direction, and another is middle one with the longer direction. So there are 3 sets of ring is there in the pedestal. And what is the ring dimension? 8 torr at the rate of 200 center. So from here we can find 3 number set, 8 torr and 200 center. So we are getting everything. So what is the dimension of the column? What is the dimension of the beam, pile cap? What is the pile cap rod and everything? Now we need to prepare the bar bending schedule. Let's jump into the bar bending schedule sheet. Here it is the bar bending schedule. So how you can make the bar bending schedule? First, we need to put the name of work, client name, consultant name, executing agency, name of work, and then what is the refer drawing number. Now here we are saying pile cap 1, PC1, 2300 into 800 into 700, the dimension, and P1 is 600 into 400. Here 2300, 800, 600 by 400. Okay. Now, bottom main bar. What is the bottom main bar? Bottom main bar, we already see the 20 dia bar at the rate of 125 center. So, 20 dia bar, number of bar, how will be? In opposite direction, that is dimension is 700, sorry, 800. So, if from 800, if we minus the cover, that is 50-50, so it will coming 7. So it will be 700, and if it is 100, so 7 plus 1, it will be 8 number of bar. So what will be the dimension of this bar? That is A, that shape is like U shape. So B is the vertical dimension and A is the horizontal dimension. What will be the A? A, this bar will distribute it from here to here in the longer direction. So 2300 is the dimension, and if we deduct the clear cover, here is a clear cover is 50 as I'm considering. So 50 minus 50, 100. So 2200. So my A dimension is 200, and what will be the my A dimension, vertical dimension? Here you can see is not going up to this. Here it is in the middle. So we are here for the calculation purpose, we are taking 500. So 2200 and 500. So this direction 500, in this direction 2200. 20 bar, number of bar, and number of bend, here is 2 bend, because whenever we are calculating the cutting length, this number of bend has to deduct it. So here what will be the cutting length? See, this plus this plus this plus this minus this bar. So it is coming to 3120 into, if we say one is 310 and total length 3120 into 8, that is 24.96, and if this bar is 20, so the total load will be this into what is the unit weight of 20 bar, that is 2.47 or 2.466. We are calculating, that is 61.55. So here, summarize the dimension in this direction 2300 minus to cover in the both sides of 50-50, it is coming 2300 2200, and vertical direct length is 500. So number of bend is 2. So 3120 is the cutting length and 249 is the total length, and the total weight of for this 20 dia bar is 61 kgs. Now in the other direction, that is bottom distribution, that means this direction how much will be? This 800, that means 50-50 minus, that is 700, and again this 50. So how much will be the number? Number will be is 2200 divided by, it is in how much is it? 100. It is coming 12, but 12 plus 1 spacing is there. So there will be 23 bar. So, okay. So again, the same way, number of bend is there. Cutting length is 1.62, and then 37.96 is the total length, and this is the 33.74 is the total weight of the 12 dia bar, because it's a 12 dia bar in the other direction, right? From where we are getting? From here. Now, the same way we need to check the top bar. Top bar is what is spacing, again top reinforcements. You can see here top reinforcement spacing here also. So top reinforcement spacing is again 12 bar is the 100 center. Okay, so we need to calculate the top reinforcement also. Here it will be 100 center. Okay, these also will be 100 center. Okay, now what will be the dia will be the top bar is a 12, and number of bar in this direction, again 700 into this is 800 minus 50 700 divided by 7, that is 7 plus 1 8, and what will be the this length? Again same 2220 and 500, because in this is in the top bar but in this direction. Okay, so again number of bend this and top distribution also 100 center. The same way the number of bar will be calculated, and we're getting the 12 dia bar. Now with the side reinforcement is 12 torr at the rate of 150 center. So it will be throughout. If it is possible to make it a throughout on in a single bar, it is, or it can be in two U bar, and it will be joined together. So according to the requirement, you need to prepare. But most of the cases is 2 bar is making. So again, this direction and this direction we need to check. The chair bar. Now, how to check the chair bar and chair length? I have made a detailed video on this, how to prepare the chair length and chair cutting length. Please check that one. You will get the full information. Link is there or in the description. The chair bar description will be okay for you. Now, we need to calculate the bar for the column or for the reinforcement. So what is the bar? Is main bar is 4 numbers 20. So first we will calculate the 20 bar. The number of dia is 20. Number of bar is 4. So what will be the calculation? You see, here is 3 is the top part, is a bottom vertical part and bottom part. See, in the top part, the bar will go and bar will bend like this. See, here it is already showing this bar is bend like this. So there will be, it is a 600, so it will be 400. 500 in the 500 in the is this direction, 600, so it will be 400. We can say 300 or the 400. Okay, because the cover will be minus, will be 400. Now this 400, now it is a 531. How it is coming? 400. How coming? It is 3803. That is the vertical one that we need to check. See, already we said 2.97 is minus 2.97 is my bottom, and the top is plus 9.77. So let's first calculate 2.97 plus 0.975. Then what is the clear cover in the bottom? Clear cover is the bottom 75 and clear cover is the top is 40. So I minus 70 minus 40, and then this bar will place on the top bottom distribution. So these two dia bar length will be deducted. So main bar is 20 and the distribution is 10, sorry 12. So 20 plus 12 is 32. So minus 32. In this way it is coming 3803. And now how 600 is coming? See, again from here, whenever this column or the pedestal is the structural and a different structural element and the pile cap is the different structural element, so this pile column is ending here and it is transferring load to the pile cap. So that is why here we need to provide the development length. So what is development length and how to calculate the development length? I have made a detailed video, link is there or in the description, you will get full information. Now for in the sake in the IS 13920, it is says the anchorage length of the development length should be 50D or LD or the LD plus 10D. So for the calculation purpose, we are saying here it's that 50D is the LD and 10D. So it will be 60D. So for 20 diawatt, 20 into 60, it will come 1200 minus, see, development is always calculating when the bar is entering into the other structure. So from here to here. So minus 700 because this depth is 700, but it is resting on the bottom distribution. So 700 minus 75, that is the cover, then 20 minus 20 minus 12, 32. In this way, it is coming 3660607. So here I am calculating is the development length is the 50D plus 10D, that is 60D. If it is mentioned in your case is the separate, then this length will be changes. So what is the number of bend? Number of bend is 2. And so this is the cutting length, this is the total length, this is the total weight. And then it is coming at this pedestal or the other bar, that is the 16 mm. Again 16 mm dia bar. Now here it is we need to calculate the development length. How it will be 60 mm. So you are calculating 60 dia bar, 60 into 6, 960 minus again total depth minus 75 is a cover, then minus 32 is a 20 by plus 10. So again, it is coming 362. So this will be number of bend 2, 4606, 36.48 because it is a to 16 dia bar. So it is coming into 16 dia length. Okay. So calculate total weight is coming here in 16 dia. See here 16 dia. Now we need there are 3 stirrups. One is full, another is separate. So full one will be the 520 into 320. Why? Because 4040 is the clear cover for the column or the pedestal. So 600 by 400. So 4040 minus is 520 and 320. And the bend is minimum 12D. So 12 into 8 into 96. So number of bend is 5. 1, 2, 3, 4, 5. So accordingly, the cutting length, total length, tonnage will be changes. The stirrups 2 is for the, see, from this one and this one. So this one you can see at 8 dia bar, it is 320 will be the indirect direction, but in the direction 1, 2, 3, 4 bar. What is the dimension? 600 and 4040 minus. So if it is minus 4040, that is 520. So 520, let's calculate 520 divided by 3 is equal to 173. 173 is the dimension in between center into 2, that is coming 3 is the 173 is coming is the center to center distance plus 8860. So it will coming around 173 is the 8 dia bar, center to center distance is 173. So 173 plus 8, it will coming at around 181. Okay, so it is coming 181. Now 181 is the other direction already 320 and number of bend is 96. Same is the 5 bend 1194 is the cutting length, is the total length, is the total tonnage, and other in this direction. In the same way, we will calculate the 400 1, 2, 3 divided by 320 divided by it is coming around in this direction 520 and in this direction is 120. Again in calculating, how much will be coming? So 320 divided by 3. It is coming 106. So it is coming 106 plus 8, that is 114. So we are taking is 120. So what if we can take 114 also. And 96 is the hook length, 5 bend dia, 146 is the cutting length, 1 cutting length, the total length, total tonnage. So in this way, we will need to calculate the bar bending schedule or each and every element. So what we cover, first we read the pile cap drawing, then top bar, so bottom main bar, bottom distribution, main bar, top distribution, side reinforcement, chair bar, pedestal main reinforcement, and the stirrups. So in this way, you need to calculate the bar bending schedule or the total tonnage of the requirement of the steel, and how this can be cut and bent and how it will be places. So I hope this one information is clear to you, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So I'm waiting for your valuable comment. From your valuable comment, everybody will be benefited. And please like, share, and subscribe. And thank you once again for watching me.